Hello, these are flip notes 2.6, the last in our unit 2 on cognition. And this is our introduction to intelligence and test construction. My Bitmoji is genius. And in this section, we're talking about how intelligence is measured and could identify somebody as a genius. Let's go.
But what is intelligence? Intelligence in all cultures is the ability to learn from experience, that you can solve problems, and most importantly, you can use your knowledge to adapt to new situations. But when we're talking about research and in school, intelligence is basically whatever is on the test, whatever the intelligence test measures, and that tends to be school smarts. When we're assessing intelligence, psychologists define intelligence testing as a method for assessing individual aptitudes and comparing them with numerical scores. So we got to find a way to get your intelligence into a number. A little bit later, Alfred Binet in France comes along, and with his colleague Theodore Simon, they are tasked with the job of coming up with an intelligence test that will figure out which children in the Paris school system need extra help. So theirs becomes the very first intelligence test, the Simon Binet Intelligence Scale. And the thing that was different about this one was that it identified a mental age, and that became the idea that your mental age might not actually match your chronological age. Lewis Terman would adapt the Simone Binet test for the US at Stanford University. So his test became the Stanford Binet. And from this, you were able to get an intelligence quotient or the IQ. So the IQ formula is your mental age divided by your chronological age times 100. And the mental age came from your score on the Stanford Binet test. So IQ could range between 0 and 200. So let's look at a couple examples here. We've got Jace, who has a mental age of 10, but his chronological age is only 8. So he is smarter than the average 8-year-old. So his IQ is 125 when we put it in the formula. You could predict that his IQ, even if you hadn't done the math yet, would be above 100 because his mental age was higher than his chronological age. Brandy over here has a mental age of 10, but her chronological age is 15. So even though she's 15 years old, she is behind mentally. And her IQ is 67, which would be considered an intellectual disability. Looking at IQ ranges, the terminology that goes with how we describe different IQs has changed significantly over time, with the most high, genius or almost genius, over 140. And terms like feeble mindedness and dullness, we don't use those anymore. But average or normal intelligence is around 90 to 109. And then below 70 is what we would consider today an intellectual disability. Looking at the normal distribution of scores, about half of the population's IQ falls between 90 and 110, with 100 being right in the middle there. 99.5 of the population between 60 and 140. So it was back in 2013 that the government officially said that the term mental retardation is not what we're going to use anymore, and it has been replaced with ID or intellectual disability. So the phrase calling somebody retarded, I mean, it's not only not politically correct, it's not kind. So we don't use that phrase anymore. We use ID if we're specifically talking about somebody who has an actual low IQ or a mental disability. When we're looking at how common in the population are intellectual disabilities, for people who are below that 70-point range, it's only about 5% of the population. And within the people who do have an intellectual disability, about 85% of them qualify for what's called a mild intellectual disability. And very few fall under the profound intellectual disability category. Looking at the opposite end of the spectrum, only about less than a quarter of the population, a quarter of 1% of the population are what's considered above average IQ. So above average is above 115. Gifted, and usually what most schools will use to qualify somebody for gifted and talented, is around 125 or higher. Genius, 145 and higher, and then highest genius, 180 to 200. Modern day intelligence testing uses a couple other tests. There's a lot of tests involved, but two of the more well-known ones are the WAIS and the WISC, the Wechsler Adult Intelligence Scale and the Wechsler Intelligence Scale for Children. On it, they're looking at a bunch of different categories, including storytelling, math reasoning, abstract reasoning, looking at digital symbols. So it's a wide range of skills and knowledge they're demonstrating on modern intelligence tests. Looking at different types of psychological tests, we have two main categories, mental ability tests and personality scales. Within mental ability tests, we look at general intelligence tests. Some early examples of this were Army Alpha and Army Beta, which were developed during World War II to assess the intelligence of our military. Aptitude tests, which you're a little more familiar with, like the SAT, and achievement tests, like the ACT, the STAR test, and the AP exams. Personality scales measure what it sounds like, personality. And we get more into that in our personality unit, which is Unit 7. Looking more closely at aptitude and achievement. Aptitude is measuring potential. So the LSAT, MCAT, SAT, MCAT is to get into medical school, LSAT is to get into law school, SAT is the general college admissions test. They're looking at what does it look like your ability will be in college or these other programs. An achievement test is backward looking. They're measuring what you've already achieved, what knowledge and abilities you already have gained. So an AP test, for example, is looking, did you achieve all of the learning that you should have, like you would in a first year psych class or college course of whatever subject that is. The STAR, looking at your achievement in maybe US history or in English. ACT, some people find the ACT a little bit easier, and that's because it's an achievement test instead of an aptitude test. For a test to be considered valid, we need to look at three criteria: the test standardization, test reliability, and test validity. All of those tests that we just mentioned, SAT, ACT, AP tests, all of those would be considered strong tests that match each of these three criteria. When we're talking about standardization, we mean that the test has been given to a representative sample before all the regular test takers, ahead of future test takers, so they can establish a normal curve or a basis for comparison. So even when they had the newer SAT set up, they gave that test to a sample population, a representative population, before they gave it to the general population. Standardization also refers to the standardized method that they give the test, where everybody gets the same amount of time, the same number of questions, it's graded the same way, same testing environment. That's also included in standardization. Standardized tests do establish a normal curve or a normal distribution, because if you get a score in a test, it doesn't mean anything until you know what you can compare that with. On a normal curve, we have that bell-shaped pattern. And I don't require you to memorize these percentages, but they're things that could show up on the AP exam later. 68% of people will score within 15 points above or below 100. Test reliability asks us, is the test consistent in what it's measuring? So a test is considered reliable if it yields consistent results. And there's different ways we can look at that. We can look at split half reliability. Assuming the test questions are weighted the same from beginning to end, if we were to divide the test into two equal halves, how consistent would the scores be from the first half to the second half? If they're pretty even or equal, then that would be good split half reliability. Test retest reliability says if we were to take that same test more than one time, if I took it in August and I took it again in January, and I didn't do anything different to prepare for the test, my scores should be pretty consistent. That's test retest reliability. The way I remember that reliability goes with consistency is, I think if my best friend is reliable, it's because she consistently gives me a ride when I ask for one. If a car is unreliable, it doesn't run consistently. Sometimes it works, sometimes it doesn't. So reliability goes with consistency. Looking at this in a graphic form, here we have scores on a first test, and then the second time they score the test. So this is some test retest reliability. Dawn here scored poorly the first time, and she scored pretty poorly the second time. Kim, she scored lower, a little below average, and then only a little bit of an increase there. Omar, he scored higher, and then he continued to score high. So this is showing reliability, that about what they got the first time is what they got the second time. This test is showing low reliability because we have drastic differences. Carl did great the first time. Why did he do worse the second time if it was the same test? Ed, he did not so great, but then his score went way up. Those don't make sense. So this test we could say is not consistent. It has low reliability. We can numerically measure the strength of the reliability of a test. If you can recall back to our chapter on research, we use correlation coefficients to measure the strength and the direction of a correlation. So if a test has a positive correlation of 0.7 or higher, that test can be considered reliable. That if your test score is high, then you'll perform well in college. If your test score is low, then you won't perform as well in college or whatever else that test is designed to measure. So 0.7 is the good correlation coefficient number we want to remember for test reliability. The next thing we want to look at is the test valid? So just because a test is reliable doesn't mean it's valid. You could be consistently wrong, but we want the test to be consistently valid as well. When we say validity, we're wondering, does the test measure what it's supposed to measure? Or is it predicting what is it supposed to predict? And there's three ways we look at content, or we look at validity. The first is content validity. It refers to the extent a test measures a particular behavior or trait. If your English teacher says we're going to do a reading quiz over chapter 3 of Huck Finn, and there's questions from chapter 5 on there, it's not measuring what it's supposed to measure. That has poor content validity. If it has only information from chapter 3, then that would be good content validity. Predictive validity is also called criterion related validity, and this says that it does a good job in predicting a particular behavior or trait. So if you were to take a practice driver's test, like an online test about the written test, and you did well on it, then that would predict that you would do well on the actual test. And if you did well on the actual driver's ed test, the written test, with your practice test, then that would be good validity. However, let's say you made a perfect score on the online test, but then you bombed the actual test. If there weren't any other factors involved, that would say that that practice test had poor validity because it was not good at predicting your performance later. Construct validity is how well a test measures theoretical constructs. And a construct is an abstract concept. It's things that are hard to define, hard to measure, hard to describe. For example, happiness, aggression, intelligence, they are hard to measure. So construct validity measures that by comparing it to other tests that have already proved valid. We'll look at an example of that here. So with predictive validity, we have scores on a pilot aptitude test, predicting who will be a good pilot, and then later their actual score in performance in pilot training. So Bob here did not do so great on the aptitude test. That's predicting that he's probably not going to be a great pilot. Over here, he doesn't do great in pilot training. Anna does great on her aptitude test, predicting that she'll be a great pilot. Turns out she scores high in the actual pilot training. So this test, this pilot aptitude test, has good predictive criterion related validity. On this other pilot aptitude test, Lori doesn't do so great. And then she suddenly does great in pilot training. So that test did not do a great job predicting. Ken, he did great on the predictive test, but poorly in the actual training. So our scores are all over the place. So this is low validity. Construct validity, remember construct is something that's hard to measure. In our example here, we have extraversion, how outgoing a person is. So we're gonna compare this test, the PSI, the expression scale of the PSI, to other tests. We have the MMPI, the Minnesota Multiphasic Personality Inventory, another part of the PSI, MMPI. These are all other personality and intelligence tests. So extraversion says you're very outgoing. This one says introversion, social discomfort, neuroticism, which is like you're anxious. These score very low. There's a negative correlation there, which is what we would expect. If we're expecting it to measure extroversion, then they should not correlate with that. Responsibility, intelligence, and tolerance, that it does, there's not necessarily a correlation. Remember, 0 means no correlation. So there isn't necessarily a correlation between those and extroversion. Sociability, self-acceptance, and extroversion, those do score positively. So it should score positive with things that are similar to extroversion and negative with things that are not. So this shows that this test has good construct validity. So mainly you want to remember that they're comparing it to other valid tests. Last part here, not really a key thing of our curriculum, but something when we're talking about intelligence and we want to look at success, I've always liked this diagram and I actually have it as a poster in my classroom. But a lot of times what we see is of success is just the tip of the iceberg. What's below it, sometimes it's natural intelligence and ability, but a lot of times it's persistence, failure, sacrifice, disappointment, good habits, hard work, and dedication. So a lot more to intelligence other than just IQ scores.